Children develop this quite early in life. As I said, primates, dogs, goats, can follow the gaze of others. This develops between 6 and up to 18 months in children. When it comes to the intention, this is unclear, but at least a chimp can distinguish between an intentional and unintentional action, and it develops in children around this age. And as I said, in humans, it comes around, well, somewhere between 3 and 4 years old. And also, this capacity to reflect on your own knowledge comes at this stage. I forgot to say that when you do the false belief test, you can ask the 3-year-old, when you came into the room, what did you think was in the Smarties tube? And the 3-year-old will say, I thought there were pencils in the tube. They can't reflect upon their own knowledge a few minutes earlier. They only think that what I know they've always known. While the 5-year-old will say that, well, I thought there was Smarties in the tube, now I know there is pencil. So this reflecting about the knowledge of others and reflecting about the knowledge of yourself develops at around the same age. And for me, I think there is, I mean, my interpretation is there is a very, very tight correspondence between these two capacities. If I can think about what you think about, and particularly if I can think about what you think about what I think about, then I can think about what I think about. So I think that these are tightly connected. Okay. Now I've given you a kind of, I don't know what to call it, a classification of the different aspects of intersubjectivity, and said something about when you find it in human children and where you find it in the animal kingdom. Now let's go back to talk a little bit, I will only spend a few minutes on this, and talk about how can we model this process. And here I borrow some ideas from, well, let me say first that controlling yourself is sometimes called metacognition. Controlling others is, well, part of controlling others to understand what others want and believe and so on and feel. And the question is, I think that these systems have evolved in parallel. And then the question is, how can we model it? And then I want to go back to these simulators. I mean, I said that when we are having motor control, we know a little bit about these simulators. I mean, people like Cavato and Volpot have been studying these motor processes. And wild speculation, still a rather wild speculation, is that similar processes are involved when we are understanding the mind of others and using that. And here I use, this is a picture taken from a paper by Volpot, Doya, and Cavato, and they make this analogy. I mean, you have this in motor control. You have this feedback loop and you have a simulation that is much quicker. Now they think that we can think of the social interaction as a similar feedback loop. I say something, I show something, I do something to you, and you give me feedback. But of course I can make a simulation, I can think about what will happen if I say this to you. If I give you this insult, what will you do to me, and so on. I mean, I have to make some kind of, I have to make some prediction of how you will react when I say something or do something to you. So we need some kind of simulation in order to make our social interactions running more smoothly than otherwise. So they developed this analogy between motor control and social interaction. And now, they don't make the distinction between different levels, but if I make a little, go through these distinctions that I made here. When it comes to representing the emotions of others, I don't think that this is, you don't need any simulations here, because what you need in order to understand the emotions of somebody else is to correlate the facial expression or bodily expression of some other individual with your own emotional state. And this can be learned by some form of conditioning. I mean, I don't think you need a very advanced learning system to do this. I'm not sure, but I don't think you need simulators here. And actually, I mean, there are these people who have made a speculation that mirror neurons use a mechanism for this cross-modal task. I mean, you have to model, to make this cross-modal connection between the facial expressions of others and the emotions of yourself. And there are some fMRI studies that seem to support this. I mean, I don't know enough about the details to tell you about them here. So probably simulators are not involved in understanding the emotions of others. It's a fairly simple learning mechanism that can explain it. On the other hand, to understand the attention of others, what you need, if somebody is looking at something, you have to follow the gaze of somebody else. And you have to find out somehow. I'll see where you're looking. I have to find out where you are looking. This requires a coordinate transformation. I can't only go on my egocentric space. I have to somehow take your eyes and transform it into my own space. So there is some kind of recalculation of two spaces. I mean, this is the direction of the gazes. I have to read your direction of gaze depending on where you're located in the room. I calculate the angles and so on, read your, and then recalculate my angle so I can find where you're looking at. My conclusion is that this capacity requires that I understand the allocentric room. In particular, if I solve the problem, you look at something that is outside my point of view. So one way of modeling this is to have not only, I mean, you have this control of the real process, you have the process emulator. This process could generate the egocentric space. And you act in relation to your egocentric space. You create some kind of egocentric space. But we can also have another emulator that generates the allocentric space. And as a matter of fact, if we want to have a system that combines information from different senses, I mean, if I take the information that I get from my hearing with the information I get from my tactile experiences, I have to create some kind of spatial information that combines this. Then we can have this emulator that takes in information from several senses and builds up an allocentric space. And then you need, mathematically, you need a coordinate transformation. And then, of course, you have to connect these two egocentric space, allocentric space, via some, well, the inverse transformation and so on. I mean, mathematically, it becomes rather complicated. But the point is that using this cross-modal emulator, you can solve many more problems than you can do without it. I mean, you can follow the gaze of others outside your own field and so on. And that's very helpful if you are collaborating about something. I mean, this is some kind of speculation of how you could generate an allocentric representation in the brain, and some kind of very rough first approximation of how a control system could handle this process. If we go higher up in the hierarchy, things get even more complicated. I mean, this is a picture from the same paper. They talk about the role of the context in this loop. I mean, if this has happened to you, I mean, if there is a milk package or a teapot or something, and you believe that the package is full, and you lift it, and it turns out to be empty, I mean, then your hand goes up in the air because your motor control was prepared for a full milk package, and since it was empty, I mean, your motor demand overshot the happening. So you have to take into account whether it's empty or full, and that will change your reaction here. They've done a model of this. What you can do then is, of course, to extend it to saying that, well, even more on a higher level, you can bring in the beliefs and desires as part of this context when you're planning your actions and so on. And these will function as hidden variables. I mean, the role of the process model emulators is to have these force variables, the mental variables that I've been talking about. They are all generated in these emulators. And now I'm really speculating. I mean, most of what I've been saying is I mean, this is trying to extend this metaphor of the brain as a control system to take into account intentions, beliefs, and desires. We need a lot more of modeling work in order to get this into something that can be handled. I mean, people like Volpert and Cavato have started the process. What I've been adding here is a little bit of dividing up the tasks that this process have to solve by separating the different components of intersubjectivity. But exactly developing this into a control theoretical model will take a lot of work that nobody has done so far.